Welcome back, children. Moving on with 7.4. Still solving log equations, but in this case we're going to be solving equations where the log is only on one side. And so in order to do that, you'll condense it down to make sure there's just one single log, and then you'll change it to exponential form. From there you should be able to solve it because you looked at how to do that in 7.3. So start with a pretty basic equation for this, just to get your feet wet. Log of 3x minus 1 equals 4. You can see the difference than what we were looking at in the last video. There's only a log on the left hand side. It wouldn't matter if that was on the right hand side. That doesn't matter, although in most cases it seems like we put them on the left. And we see that there is a base here. It's just not written, so we know it is 10. It's an assumed base. And so I'm going to change that into exponential form, leaving my 3x minus 1 here, taking the base meaning it's what's being raised to the exponent. And so my base of 10 is raised to the 4th power. I'm going to solve or evaluate what 10 to the 4th power is. That just means there are a 1 with 4 zeros, and so I end up with 3x minus 1 equals 10,000. Algebra 1 equation, add 1 to that, 3x equals 10,001 divided by 3. X equals 10,001 thirds. If you want to try to simplify that, remember you don't have a calculator. You may try to. Don't matter to me. Excuse me, doesn't matter to me. Leave it like that if you want. Doesn't matter to me. You should check to make sure that when you plug it in, you do have a positive value that you're taking the log of. But when you multiply that by 3, that's definitely going to be greater than 1. So yeah, I'm going to have a positive value. Checks out okay. Example 2. Zwei for all you Germans out there. Log base 2 of b plus 4. We're going to change it up a little bit, get crazy with the different variable. Minus 3 equals 1. Okay. I do still have only one log, or excuse me, log on one side of the equation. However, I've got other values that are not included in the log that have to be taken to the other side. So you have to isolate the log by itself first before you can begin to change it into exponential form, which means this minus 3 is not a part of the log, and it's got to be added to the other side. So I end up with the log base 2 of b plus 4 is equal to 4. Now I'm going to change it into exponential form. B plus 4 equals 2 to the 4th. You should know this. No need for a calculator. You're not getting one on the test. Might as well learn it now. B plus 4 equals 16. Subtract 4 from both sides. B equals 12. You could take pretty quickly and plug that back in there. 12 plus 4, that's going to be a positive value. It's actually 16. We know that we'd be taking the log base 2 of 16 and set it equal to 4. So 2 to the 4th is equal to 16. It checked out as being accurate. This one we actually could check all the way to the end. This one, we could have. Okay, we'll go back and look at this real quick. If I'd put 10,001 thirds and multiplied it by 3, well, this 3 and the denominator of 3 would have canceled out. I would have been left with 10,001 minus 1, which is 10,000. So 10 to the 4th power is 10,000. It checked out. We're good. Moving on, example 3. Now you get back to work. 6 plus 2 log base 5 of 2x plus 3 equals 12. Holy smokes. We got stuff going on here. First off, Let's make it more interesting. Let's make that a negative 2 and a negative 12. No, I lied. Positive, positive. I'll just get over it. Alright, so the first thing, we've got to isolate this. So it's kind of like our unknown, which means we've got to get the 6 and the 2 over there, but the 2 is what's being multiplied, and the 6 is what's being added, so we start with moving the 6 first. So we're going to subtract 6 from both sides. Leaves me with 2 log base 5 of 2x plus 3. If I subtract 6 from both sides, this leaves me with 6. This is 2 times the log, so I'm going to divide both sides by 2. Now I've got my log isolated. 6 divided by 2 is 3. Single log equal to something means change it to an exponential form. This becomes 2x plus 3 equal 5 to the third. Yeah, I would expect you should know what 5 cubed is by this point, if you've really been doing problems without your calculator. That's 2x plus 3 equals 125. Subtract 3 from both sides. 2x equals 122 divided by 2, x equals 61. You can plug that back in. It's going to give you 125 in there, which is what we know that we would end up needing. Bam. Let's go one more. Log base 51 of 3x squared plus 63 equals log base 51 of 2x plus 4x square. Ah, you can't see. Just kidding. My bad. So I don't know how much of that you couldn't see. Now you can see it all. Pause it if you need to go back and look at it. Moving on to this one, however. Log base 51 of 3x squared plus 63 equals log base 51 of 2x plus 4x squared. What do you notice about this problem? Yes, you're right. This has a log on both sides. I was just checking to see if you were paying attention. This goes back to 7.4, but part 1, when you have the log on both sides, you need to condense it into a single log on both sides, which it already is, and we just dropped the log. So I'm really solving an equation, 3x squared plus 63 equal to 2x plus 4x squared. Thank goodness, because that was a big old base. Now I'm going to solve this equation. I really didn't even need the parentheses anymore. It's a quadratic, which means I want to set it equal to 0. So in order to have a positive x squared, I'm going to subtract 3x squared from both sides, which leaves me with a single x squared over here. And then I've got a positive 2x. I just reordered this, so it's in descending order. Then I'm going to subtract 63 so that I have 0 on this side. And I've got a fantabulous quadratic equation. X squared plus 2x minus 63 equals 0. This is factorable. Thank goodness. I didn't feel like using the quadratic formula today. It factors into x minus, nope, lied, x plus 9, x minus 7. 9 times negative 7 is negative 63. That would give me 9x. That would give me negative 7x, which would be a combination of positive 2x and, of course, x squared. So my values of x are negative 9 and positive 7. Do they both actually work in this problem? You can do a quick check. Well, putting in the positive 7 7 squared is 49 times 3 plus 63. Let's pull out the calculadora. I got old Yeller out this time. 3 parentheses 7 squared plus 63. That's 210. So I'm looking at log base 51 of 210. I need to get 210 on the other side. So we'll plug in 2 times 7 plus 4 parentheses 7 squared. Bam! 210. This one checked out. Let's double check with our -9. Make sure it works. 3 parentheses -9 squared plus 63. 306. Let's check on the right. So 2 times -9 plus 4 parentheses -9. Close them up, square it, equal it. 306. Bam. Checks out. 2 possible solutions. End of story.